All right, welcome today to my tutorial. Today we're going to be talking about translations. And this is a translation, is basically a slide. But before we start translations, we got to talk about all the different types of transformations, because a translation is a type of transformation. So what is a transformation? It's basically when you take a pre-image, which is your original, and you transform it to make an image, which is the copy. So we got the pre-image, the original, and the image, which is the copy. Now there are two types of transformation. A rigid transformation does not change the size or shape of the pre-image. In other words, it's the same area, same sides, or the same length, same angles, interior angles. While a non-rigid transformation will change the size of the image, the pre-image, but not the shape of it. Okay. Now, there are, again, the two types. We got the rigid and non-rigid. And here we go. Here's some examples. In a rigid transformation, we end up with congruent shapes. And non-rigid transformations, we end up with non-congruent shapes. So a non-rigid for us is basically going to be where we make a shape larger or smaller. While a rigid transformation, we're going to flip it, rotate it, and or reflect it. So what is a translation? Well, a translation is a type of transformation. We're going to move an object in space without changing its size, shape, or orientation. And it is a type of rigid transformation. And a translation is basically a slide. So you can see from this blue shape, it's sliding to the right, and its size and shape and its orientation are the same. And that is the first type of transformation we're going to deal with, called a translation. All right, so let's get started. Here, we are going to translate an image 5 units to the left and 6 units down. And we're asking for the coordinate notation. Now, the coordinate notation is, what we have to do is we've got to take our original XY values for each vertex, or each point, as some teachers call it. So first thing we're going to do is we're going to figure out how we're going to move the X value. Well, the X value in each vertex or point is going to move 5 units to the left. Now, X controls left or right. So if you go to the left, is X going to increase or decrease? What's going to decrease? So you're going to take each X value and you're going to subtract 5, which is going to decrease it 5. At the same time, the Y values are going to go 6 units down. Y controls up and down. If you go down, what is happening to your Y value? It's going to decrease, and in this case, we're going down 6, so it's going to decrease by 6. All right, so let's start off with point H. Let's translate it 5 units left and 6 units down. So we're going to count 5 units to the left, and then we're going to count 6 units down, and then we're going to put a new point or vertex, and we're going to label that H prime. Then we go on to the next vertex, in this case J, point J, and we're going to do the same thing. 5 units left and 6 units down, put a point, and so we're translating vertex J, so we're going to label it J prime. And then we're going to continue with vertex I, same thing, 5 units left, 6 units down. We are translating vertex I, so we label it I prime. And then we go ahead and connect our vertices. And as you can see, we have a copy of triangle HIJ and triangle H prime, I prime, J prime. They are both congruent. They have the same size of sides. Okay, let's move on to the next one. Here we're going to translate this image 3 units right and 6 units up. Again, we want to write the coordinate notation. Each X and Y value, we're going to go 3 units right, so we're going to add 3 to each X value, because when you go to the right on the X axis, X increases. And we're going to go 6 units up on the Y value, and so when we go 6 units up, the Y value increases. And so each Y value, we're going to add 6. Okay, so let's go ahead and start with vertex P. We're going to go 3 units right and 6 units up. And since that's a translation of vertex P, we're going to label it P prime. Let's go to vertex O. Once again, 3 units right, 6 units up. We translated it point O or vertex O, and we're going to label it O prime. And let's do the same exact thing, 3 units right and 6 units up for point N, and translate it, and we're going to label it N prime. Then you connect your values, your points, making sure you connect the same as the original. So in other words, you should have a line segment ON and O prime N prime. And these two triangles, triangle NOP and triangle N prime O prime and P prime, they are both congruent, and so we have a rigid transformation. The next type of way you're going to see translation is where you're going to be given the coordinates, and you got to come up with the corresponding values, coordinates of X and Y, with an order pair that has been translated. So we're going to take these vertices and we're going to translate them 5 units right and 2 units up. So what you need to do is you need to write your coordinate notation. Here we got the original X, Y. Since we're going to go 5 units right, the X controls left and right, and we're going to increase by 5 because towards the right, X values increase. The Y value is going to go 2 units up. Again, Y controls up and down, and if you go up on the Y axis, Y is increasing by 2. And then that's going to yield you X prime and Y prime. All right, so what we want to do is we want to start off with one of the vertices. Here we're going to start with vertex W. We're going to write down the original coordinates. So since we are taking our X value, we're going to add 5. We're going to substitute our X value, which is 0, and then we're going to add 5 to it. The Y value, since we're going 2 units up, we're going to take our original coordinate of 3, and since we're going up 2, we're going to add 2 to it. And then what we do is we're going to go ahead and come up with vertex W prime. And so basically you just simplify. Our X coordinate is 0 plus 5, and that's going to give us 5. Our new Y coordinate is going to be 3 plus 2, and that's 5. And so W prime is the order pair 5, 5. Then we go on to the next one. Let's go ahead and start with vertex X. We start off with the coordinate 6, 7, or the order pair 6, 7. We're going to take the original X value, which is 6, and since we're going 5 units right, we're going to add 5 to it. Then we're going to go and take our Y coordinate and go 2 units up. So we start off with the original value of 7, and we're going to add 2 to it to make up for the 2 units up. And X prime is going to be the order pair 11, 9, because 6 plus 5 is 11, and 7 plus 2 is 9. And we're going to go ahead and do that with all the rest of the coordinates. Here we got Y. Start off with the order pair 4, negative 3. So the original X value is 4. We're going to go 5 units right, so we're going to add 5 to the X value. We're going to go ahead and start off with our original Y, negative 3. We're going 2 units up, so we're going to not subtract 3, I'm sorry. It should have been add 2. I made a mistake. And so we end up with the order pair 4 plus 5, and we should have the order pair negative 9, negative 6. So I want to go ahead and I changed it. We end up with the order pair 9, negative 1. And let's do the last vertex Z, the order pair 2, 0. We're going to add 5 to the X value. Then we're going to subtract 3. But again, that is incorrect. Let me fix that. We're going to add 2, and we end up with the order pair not 7, negative 3, but the order pair 7, positive 2. All right, let's go ahead and go on to the next problem. Same thing. This time we're going to translate each vertex 4 units left and 2 units down. Once again, go ahead and start off with the coordinate notation, which is the order pair XY. We're going to go 4 units left. So that means left is controlled by X, so it's going to decrease by 4. Then we're going to go ahead and annotate the Y value. It's going to go 2 units down, and when Y goes down, it decreases by 2. And that's going to give us the order pair X prime, Y prime. So let's go ahead and do the vertex G. Start off with the order pair G, negative 6, negative 2. We're going to take the X value, which is negative 6, and we're going to subtract 4 for it because we're going 4 units left. We're going to take the Y value, which is negative 2, we're going to go ahead and simplify negative 6 minus 4, which is negative 10. And again, another mistake. And we should end up with the ordered pair negative 10, negative 4. All right, let's do the next vertex, vertex J, which is the ordered pair negative 5, 0. We start off with negative 5. We're going to subtract 4 because we're going 4 yet left. And we're going to subtract 2 from 0 because we're going 2 down. That's going to give us H prime, vertex H prime, and that's going to give us negative 5 minus 4, negative 9, and 0 minus 2, which is negative 2. So we end up with the ordered pair negative 9, negative 2. And last but not least, well, let's continue with I. Ordered pair I is the ordered pair I1, negative 4, excuse me. We're going to take the x value, which is 1, subtract 4 from it. We're going to take the y value, which is negative 4, subtract 2 for it, and we end up with the ordered pair negative 3, negative 6, which is I prime. 1 minus 4 is negative 3. Negative 4 minus 2 is negative 6. And now let's do J. The ordered pair negative 6, negative 3. Again, the x value, we're going to subtract 4 from each one of them, in this case negative 6. And then the y value, we're going to subtract 2, in this case negative 3. We end up with J prime, which is the ordered pair negative 10, negative 5. Now, as you can see, you're going to have to write the coordinate notation for these, and even for future transformations that we do. The translation is one of the easiest where you can do on the graph, but just make sure you guys write the coordinate notation and you'll be set up perfectly. Now, in review, we're going to talk about transformations. We got rigid transformations, we got congruent transformations, which are rotations, reflections, translations, and that's the ones we're going to do. And then the non-rigid transformations are going to be the dilations. And we're going to go ahead and take care of that in future videos. Dilations, though, can be rigid transformation if the scale factor is 1. So you don't have to know this yet, but just make sure you guys are aware of this. And when you get through with all the transformations, which are the rotations, reflections, translations, dilations, you should be able to know this material here as in order to make sure you know everything. You want to know that transformations, we have 2 types and the names of them that are rigid and non-rigid. Okay, thank you for watching. Be on the lookout for my next video tutorial. Thank you. Goodbye.